Okay, so this tutorial is going to walk you through how to do the chi-square test. Remember, on the AP Bio exam, you're going to be given the chi-square formula. They're going to write it a little different. It's just going to say chi-square is equal to O minus E squared over E. And usually you're going to see this little summary or summation here. You're also going to be given some kind of form of this chart. So you're never going to have to memorize the formula or the chart. You just need to know how to use them. So a chi-square analysis is a statistical way of accepting or rejecting a hypothesis rather than it being subjective of whether you think the results are close enough or not. You're going to actually get a numerical result that will tell you whether your hypothesis is acceptable or not. So it's often used in a genetic test. So for example, in this case, tall is dominant to short in pea plants. A heterozygous tall is crossed with a short. What is the genotype and phenotype frequency of the offspring? And then they give you some data. So the first thing that you want to do is you want to do your typical Punnett square. We're going to use t's, and we're crossing a heterozygous with a short. When we do this, our expectation would be basically that we're going to get half tall and 1/2 short. So that's our expected. Okay, so now what we do is we look at their actual results. So our two phenotypes are tall and short. We're going to write down our observed results. This is going to be our total. So our observed results are that there's a total of 360, 190 are tall, and 170 are short. The next thing we're going to do is we're going to calculate how many we expected to be tall and short. So if we take 360 and we expected half of them to be tall and half of them to be short, we basically do 360 times 1/2, and that gives us 180. So our expected for both of these in this case is going to be that we expected 180 to be tall, 180 to be short. You'll always just take the total and multiply it by the fractions that you predicted, and that's going to give you your expected. The next thing we're going to do is we're going to calculate chi-square. Even though it's called chi-square, you're never going to take the square root or anything. It doesn't have to do with anything being squared. So what you do is you basically just plug this into the formula. So we're going to do 190 minus 180 squared over 180. And then we're going to do the same thing here, 170 minus 180 squared over 180. If we subtract that, you're going to get 10, and 10 squared is 100. So for each of these, it's going to be 100 over 180. And we get that chi-squared, if we round this, is 0.56. Now remember, our full formula was that it's the sum of your observed minus expected squared over your expected. So that means that what we're now going to do is we're going to add these together. So 0.56 plus 0.56 gives us 1.12. Okay, so now we have chi-squared. Our whole goal was to get this number. Our last step is we're going to go to the chi-squared table and see where this number falls. So here's our table. The rule for the table, first of all, there's this thing on the left called degrees of freedom. This is going to tell us which row to look at. 1, 2, 3, 4, 5. When you're doing a chi-square analysis, you basically use, it's the number of possibilities. In this case, we're talking about the number of phenotypes we had, minus 1. So in that case, we had two phenotypes, tall and short. So that would be two phenotypes minus 1. We're going to be looking at row 1. So these numbers on row 1 are all here. Our chi-square, I forgot what it was, 1.12. So what we're going to do is we're going to go all the way across this row. We're going to find where 1.12 falls. And it happens to fall right here in between 1.07 and 1.61. Now, these numbers at the top of each of these, this sort of represents the probability that you could be off by that much and everything is still okay. In other words, if you fall, our cutoff point is always 0.05 or 5%. If your number falls to the right of this line, that means there's a less than 5% chance that you should be off by that much and still have your hypothesis be correct. So your final answer on this is just going to be what chi-square is equal to. So chi-square equals 1.12, and you accept your hypothesis because it falls in the acceptable range. Sometimes people will actually write, since it falls between 20 and 30, that it falls in the 20-30% range. However, that's not necessary because they're actually going to give a simplified chart on the AP exam, and you're not actually going to have that information. You're just going to know the cutoff, and you're just going to need to know that it shouldn't fall to the right of the cutoff. So let's try one more genetics problem. So this one's a little harder. Tall is dominant to short, red is dominant to white. You cross a tall red with a short white, and they want to know the genotypes and phenotypes of the F2. So we're going to work this out really quickly. So they want you to cross basically this: a tall red, a short white. The F1, hopefully you don't need a Punnett square for that, is going to be this. And then they want you to cross two of those. So before we do that, remember the easiest way to do that is use the product rule, separate the two. Before we do that, let's go ahead and make our chart. So if we look at the results, it says that we have a certain number of tall and red, tall and white, short and red, and short and white. So these are the four phenotypes that we're looking for. So we have tall red, tall white, short red, short white. All right, and then we're going to make our same thing. It's always going to be our observed, our expected, and our chi-squared. And our whole goal of this entire thing is going to be to get this, our final chi-square, so that we can go to the chart. So in this case, if you do the cross, you're going to see that you're going to get this basically. 3/4 tall, if we do this real quick, you're going to get 3/4 tall, 1/4 short. And if we do the same thing with red, we're going to get 3/4 red and 1/4 white. Okay, so we're going to fill out our observed. So we had a total of 500 offspring. If they didn't give you that, you would simply total up the numbers they gave you to get the total. We had 300 tall and red, 82 tall and white, 78 short and red, 40 short and white. To figure out our expected, what you're going to do is you are going to calculate it. So the chances of tall and red are 3/4 chance of tall times 3/4 chance of red, and we get 9/16. So we know we're going to need 9/16 here. If you work out the other three, it's going to be 3/16, 3/16, and 1/16. So now what you're going to need to do is take your total, and be careful and make sure it's the total, 500. So you're going to go, okay, so I need to know what 9/16 of 500 is, which comes out to 281.25. And it's okay to round because you technically can't have a quarter of a plant. So we're just going to say 281. We're going to do the same thing here. 3/16 of 500 is going to give us 93.75, so let's just round that up to 94. And then this is also going to be 94. And then finally, we're going to do 1/16 of that, and you're going to get 31.25, so we're just going to say 31. And this should still add up to 500. Okay, and now we're going to calculate chi-square from this, just like we did before. We're going to do observed minus expected squared over expected. Okay, so to speed things up, I went ahead and I did our calculations, and these are our 4 separate chi-squares. We sum them, and we get 8.14. Now we're going to go back to our table right here. I'll get rid of all my writing on this. And we said it was 8.14. Now this time we had 4 phenotypes. That means, remember, it's the number of phenotypes minus 1, so we're going to go to row 3. And we're going to find where 8.14 falls. If we go all the way across the table, here it is. 8.14 falls here. Our cutoff is always this one right here, 5%. Since this falls to the right, we're going to say that we reject our prediction. Which doesn't mean we necessarily did anything wrong. It could mean Maybe they weren't purebred in the first place. Maybe the genes are linked. It just means that we either need to repeat our experiment or we need to check into maybe some other genetic thing that's going on because it's not following the expected ratios we should have gotten. All right, for our last problem, I'm going to show you one that's not a genetics problem. Okay, so for this one, we're doing just an experiment. We want to see if experimental results match our predictions. Now, the easiest way to do this type of problem is to create a null hypothesis. Because even if you think, if you recall, we did pill bugs. Even if you think they're going to prefer the dark to the light, how are you going to make a hypothesis? If you think they prefer the dark, what are you going to say? They're all going to be in the dark, half of them are going to be in the dark. You're not really going to know what to predict. So instead, you're going to make a null hypothesis that basically just says pill bugs will not be affected, or something along those lines. They will not be affected by the amount of light. That way, if it does fail the chi-square, you have proven that there is a statistical difference, that they do seem to have a preference. So, we are putting them in a dish. It has 4 separate chambers. One's dark, 40% shaded, 60% shaded, and fully lit. So these are going to be our 4 possibilities. Dark, 40, 60% shade, and then fully lit. We're going to do our same thing, observed, expected, chi-square. The only thing that's going to be different in this one is whenever you do a null hypothesis, you're predicting that there's going to be no difference. By predicting there's no difference, it makes it really easy to make your predictions. So we had 84 bugs, and we predicted 30, 20, 24, and 10. 30, I'm sorry, 20, 20, this is our observed. So what you're going to do for this, for expected, a null hypothesis says there'll be no difference. So for an expected and a null hypothesis, you always just take your total and divide it by the number of options. That means we expect there to be the same number in each, because if they're unaffected by light, they should randomly just end up scattered equally. So 84 divided by 4 is 21. So here's our prediction, 21 in each one. And now we do our chi-square just like we did before. Okay, so if you work this out, these are the 4 numbers you should get. You add it up, and you got 10.1. Just like before, we're going to take our chi-squared, we're going to go to the chart. 10.1, we're going to look at row 3. There were 4 options of where they could be. Number of options minus 1 gives us 3. And 10.1 falls over here between the 5 and 1%. Here's our cutoff, 5%. And so this basically says that we are going to reject our null hypothesis. And what that really means in a case like this is that there was a statistical difference. In other words, we have found in our results that it does seem like there's a preference to go towards dark or light, or there's something. And we could then go from there and experiment further to figure out what they prefer. So that's how you do a chi-square test.